Hello and good morning. Please, can you hear me?
Yes, sir.
Okay. You're welcome to second semester. I hope you had a bit of rest before we start our second semester. Um, I pray that you will be able to go through this as well. Um, Unlike algebra, this is a bit technical, this topic, but we'll do our best so that we can all be on the same page. I also want to take this opportunity to thank all of you for your good wishes on my birthday last week. I'm grateful. I pray that wherever you got whatever you got from, the Lord bless all of you. Okay, so this morning we want to look at the course outline for this course. What entails in the what we call discrete structures, and then we'll delve into the first topic, logic, propositional logic. Is quite um, involving, so I'm breaking it into 2 weeks. We'll do the laws this today and look at the truth table and the connectives. And God willing, next week we'll look at how to use it to prove things like valid arguments, logical equivalence, and stuff like that. So that is the plan for this morning. We'll see a lot of examples. I've already shared the Socrative room name, and I could tell some of you are getting all correct. I don't know what you did to get all correct. I hope you are doing it from your, well, let's see how it goes. But so far, what I'm seeing, it seems as if you are acing the whole thing. Okay, so let's start with the course outline. Um, Okay, so this is discrete structures. It's a course taken in second semester for IT. The computer science calls it discrete mathematics, but the contents are very similar. The first part has my details, all the information about the course and about me and my office. It's in the first page. Then the second page, we have the description. So hopefully we'll be looking at logic today, but actually it starts from set theory. Last semester, we didn't go too much into sets, but we're going to look at set theory and the Venn diagrams that set theory has, the operations on sets, things like union, intersection, complement, and then how to use it to represent what we call Cartesian product relationship that conforms to Cartesian product. What is the power set of a set? And then we'll take it to functions. Functions will bring us to things like relations, when is a set supposed to be reflexive, symmetric, and transitive, and then have equivalence relation. So we'll see all that in relations, and then we'll look at functions. What is the domain of a function? What is the range of a function? What is one-to-one functions, surjective functions, the inverse of a function? Last semester, we dealt with series and sequence. So we would need not go over this. We may take some applications to that. Then we come to counting techniques. Counting takes us to principles like the pigeonhole principle, the inclusion and exclusion principle, yeah. Things like permutation. When do we use combination? Last semester, the last question was on combination. So we saw a use of it. And then the use of a Pascal triangle. We saw that also last semester. The latter parts of discrete will deal with Boolean algebra. Part of Boolean algebra that comes from what we'll do today. What is a truth table? What are the truth values? What are the properties of Boolean? Now, there is also a topic called the methods of proof, where we'll look at proofs like direct proofs, indirect proofs, contrapositive proofs. Induction, I told you induction was in second semester, but there was a question on it in the first semester. And the last topic will be on graph theory. Graph theory, what is a directed graph? What is an indirected graph? How do you use graph to be able to find the shortest distance between 2 points and to determine the possible road networks? So the course description is very involved, and there's quite a lot of things here, but we are going to take them week by week and see how best we can address all the topics that are relevant to your course. Okay, so let's look at the material. At the end of the course, you should be able to know how to solve problems creatively. Unlike algebra that we have formulas, here there are rules that we need to follow. If we follow the rules, then we can solve our problems. How do we able to construct proofs and understand them? How do we able to exercise what we call the common mathematical argument? By next week, you'll see some arguments that we will come across and how to handle them. And then we must be familiar with certain mathematical notations. What is the use of symbol for all there exists and stuff like that. And then the basic principles and sets, functions, the topics I mentioned, counting techniques, Boolean algebra, and graph. After all this, you should be able to enjoy the course, so you should have fun. If you don't enjoy this, you don't enjoy the course, it will influence even how you study to be able to write exams on it. Okay, so that is the learning outcome, but the student outcome at the end, perform operations on sets, solve mathematical proofs, propositional logic, discuss the types of proofs that are conducive for a problem. When do we use combination and permutation? Solve problems in graph theory and understand them and apply the rules of Boolean algebra. These are the things you should be capable of doing when we are done. The books that are necessary for this course, there are these books which I am using. Today I haven't taken my time to search for these books online, but normally I tell students to go to show you a website. I showed the engineers this morning. Wonder whether it's open. And it's okay. So, but the website is www.allshare.com. Okay, so if you come here and you have a Gmail account and you type the name of the book, for example, Discrete Mathematics, if you type by Kenneth Rosen, that's one of the books that we use. You see that the book is here. That is a book and it has a solution manual and you can download it. So if you look at the course outline I'm going through, okay, this one, for example, Discrete Math for Computing by Rod Haggerty. For a long time, I don't see it available. Discrete Math for Computing by Rod Haggerty. I'm not sure whether it's available here. Okay, so you see, I don't see it here. The other books for computing is a book that is still being, so you see it on Amazon. So you can take your time and type these books, Fundamental Approach to Discrete Maths. check this by fundamental approach. I think by, yeah, that's it. That's the name. And fundamental approach to life. Fundamental approach to life. This is not what I want. Okay, I don't see it here as well, but I have e-versions of some of these books. So if you're interested and you want them, then you can send me a Telegram hi, and I can drop in Telegram. So WhatsApp and email, we can't send them unless maybe I encrypt or I zip the file. Okay, so these are the books. There are quite a number of them. Discrete Math by Harold Hagerty, Discrete Math by Kenneth Rosen, Fundamental Approach to Discrete Math, An Open Introduction, Discrete Maths, and then American Society Discrete Math. They're all discrete mathematics books. Okay. Now, you know how we do our assessments. There's always individual assessment, which are quizzes. The quizzes, like we did last semester, I hope this semester you will take advantage of what we did last semester. So, for example, today, at the end of today's lecture, there will be a simple quiz at the bottom of lecture 1, Introduction to Logic, Truth Table, and Argument, Valid Arguments. And the quiz is 15 MCQs. So this is that quiz on logic and valid argument. It's running to 20th August. Okay, so kindly take note of it. You can take advantage of what we are learning and practice these quizzes. Maybe we may have to wait till next week to understand valid argument, but it's here. So that is what I'm talking about. There are individual quizzes, which are on the LMS. There are group assignments, which you also see on the LMS. And then almost every day, every lecture, we may have a Socrative quiz. Then you have your mid-semester exams, which is also will be online, and then your final exams. So just like last semester, the structure is the same. We'll follow through in the same way. Then the topics for each week basically have been designed in the format of the module book. So today, like I said, we are looking at from here all the way up to somewhere here, maybe all the way up to here. With the things we'll do, we'll see examples up to here. And then to be left with the last one, argument. And we'll try and do that hopefully next week. Okay, so that is the outline. So now I'm going to share my PowerPoint to take care of what's the definition of a propositional logic, how do you draw truth table, and the connectives, the rules for connective, when do we have logical equivalence, what predicates logic, we'll see that next week or so. And then we have tautology, contradiction, contingency. All this will show up in propositional logic. Okay, so let's take them one by one and see how you fare with this. Now, I am going to take them in this format, and let me know if something is not clear, because this is virtually the foundation, and you have to understand the definitions very well to appreciate how to solve problems in logic. Okay, so the first one is the definition of what we call a logical statement. Why are we studying this subject? Because the rules in this topic, the rules of logic, helps us to be able to design what we call suitable reasoning, suitable argument. How do we use it to be able to solve arguments and how to solve problems digitally? All the things we are learning, they can be designed into digital system that helps you to either simplify or complicate a situation. But whatever it is, the rules here are very important. So we need to understand the rules very well. Now, then, what is the definition of a proposition, not preposition, P-R-O, a proposition. Now, this is a statement that has a truth value. So any statement that we claim that it is either true or it's false, then that statement is a proposition. So we are going to interrogate this definition carefully. And then when we are done, if I'm sure you get it, I'll show you a past question so that you appreciate how questions are asked on just this definition. A proposition is a statement that has a truth value. It is either true or it is false. If it is true, it will be labeled T or the value 1. 1, just like binary numbers, means true. 0 means false. So if we are not using TF, we'll be using the values 1 and 0. Okay, so let's take these examples. Now, what we want to test or what we want to understand is, are these statements propositions? Now, if they are propositions, then those propositions must be true or must be false. So we have to check each statement and check whether they are propositions. So the first one, let's do this together. Today is Monday. Today is Monday. What do you think? Is it a proposition?
Yes.
Yes, it's a proposition. Okay. Why is it a proposition? Because the statement is false.
Yeah.
Isn't it? Okay. Now, the second one. 5 plus 2 is equal to 7. Again, is it a proposition?
Yes.
Yes.
Yes, it's a proposition. This time, the statement is true. Okay, so it is a proposition. Now, let's take the third one. 3 times 6 is greater than 18. Is this a proposition?
Yes, it's a proposition.
Yes,
It is.
yes, this is also a proposition. Okay. The sky is blue. The sky is blue. Is it a proposition?
Yes.
It's a proposition.
Yes, that is also a proposition. Good. Then, why is the sky blue? Is this a proposition?
No, please.
No.
Okay,
No.
so when we have questions, they are not propositions. Now, let's look at this. Nelson Mandela. Is this a proposition?
No, please.
No.
No.
Okay. Then 2 students in this class or in the class have a CWA or a GPA of 3.275. Is this a proposition?
Yes.
Yes, it's a. Somebody said no. Why is it not a proposition? Why do you think it's not? The one who said no, what is your reason? Okay, there are those who said yes. Why is it a proposition? Maybe to help those who are saying no. Why is this a proposition?
That statement can either be yes, true or false.
Okay, Nathaniel and Ampa, I heard you. So this statement can either be true or can either be false. Actually, you've all written an exam. So all of you, by the time your results are published, you will know what your CWA is or GPA is. So some may get 3 point something, some may get above that, some may get below that. So this statement obviously will either be true or false. And we said a proposition is a statement that we can determine that it is either true or it is false. Okay, so it is a proposition. Okay, now let's go on. This sentence is false. Is it a proposition?
It's a proposition.
Yes.
Yes, also this one too is a proposition. Okay, then this last one, the current king of France is bald. Is this a proposition?
Yes, please.
Yes.
Okay.
Yes.
Okay, so all these examples that we've given, we are claiming that they are proposition. Now, before I leave here, I want to introduce another example. If I give you 5x plus 200 is equal to 4,000. 5x plus 200 is equal to 4,000. Now, if I ask you, is this statement a proposition? Will you say it is or it is not?
It is.
It is a
Yes, it is.
proposition.
Yes.
Okay, now let me find out why you're saying it is a proposition. How do you know that it is true or false? How do you know?
Because you can work this out to find out if the answer for X.
You know that the only way you can work this out is when you assume that this statement X is a variable. You have to assume that this statement X in the first place must be a number.
Yeah.
Isn't it? But I have not given you any information. I've not given you any information that suggests that this X is a variable. I haven't done that. So how do you know that when you solve, you are going to get a solution that is either true or false?
So
You follow?
we
Yes, go ahead. Oh, who was volunteering the information? I want to hear your argument. Or maybe the person was disconnected. Okay, but any other person, do you think you can determine the truth value if the domain of X is not defined? If X is not defined, can you determine whether this statement is true or not true? Is it possible?
No, sir.
No.
So generally speaking, this is an equation. 5 plus 2 is equal to 7. It's an equation involving addition and numbers. This is also an equation involving numbers. This is an inequality. But this one, it is an equation involving numbers and a variable. And you know that this variable, if we know that the variable, let's say I tell you that X is a positive integer, then you know we can solve this. I know whether there's an X that when you multiply by 5 and add 200, we all call to 4,000. Okay? Or if I tell you that X is a fraction, it's a rational number, a fraction, is there a fraction that multiply 5 and add 200? It will be equal to 4,000. If I define the X, then you can know whether it's true or not true. But at this stage where I have not defined the X, you cannot tell that this statement is true or it is false, because you cannot assume that 5x means that 5 times a number. It can be 5 times number of houses plus 200 websites is equal to 4,000 newspaper review. It could be something like that. Depends on what the person is trying to explain. So to be safe, statements with variables without the variables being defined are not propositions. Statements with variables and the variables are undefined, they cannot be proposition because we cannot tell the truth value of those propositions since we don't know the domain of the variable. But if the variables are defined, then yes, we can tell whether the statement is true or not true. Okay, so based on what we've seen so far, Angela, your hand is up. What's your question, please?
Okay, sir, good morning. Please,
Good
you
morning.
said if the variable is not stated, you cannot say it's a preposition. So let's say with this question or with this equation, if you solve for x, you get 760. So if you make the equation 5 into bracket 760 plus 200 is equal to 4,000, can you say that is a preposition because the variable is stated?
Okay, Angela, that's the point I'm making, that you were able to solve for x because you assume that x is a number. Okay, you made that assumption. So if we are told or you have a prior knowledge that x is a number, then you are right. Then this statement will be true. That is x equals to 760 will solve this equation. Any other value of x will make this equation to be false. Then it is a proposition, either true or false. But again, we don't know. It has not been defined. So you can't assume that that equation written, X stands for a number. And so because it is undefined, we cannot tell that it is true or it is not true. We are going to look at this types of relationship, hopefully in a week or two, where you have statement with variables, and you understand this definition very well. But at this stage, based on the definition of a proposition, we must stick to the rule. Can this statement be true based on the information given? Can this statement be false based on the information given? No assumptions made. I hope you get it. So if we are not able to tell whether or not a statement is true or not true based on the information given, then it is safer to say that this is not a proposition. Okay, so Angie, you are right. If X is 760, then we can say it's true. Any other number will not be true. That is assuming X is a number, but you must be provided with that information before you can even take that step.
Okay, so
okay. So now let's generalize what we've seen so far so that when you see a problem, you can easily tell whether the statements are either propositions or not. So here we are saying that statements that are questions are not propositions. So what is your name? It's not a proposition. Statements that seems to be given an exclamation. You saw an example of Nelson Mandela. Now, depending on how you speak about that name, it can be an exclamation, somebody expressing the awesomeness of that man or what they did or what they didn't do. So it could be an exclamation. So Nelson Mandela doesn't have a truth value. Then command, sit down, close the door. When you give a commanding statement, there are no truth value to that statement. You can't say it's true. You can't say it's false. It's a command. It's either obeyed or disobeyed. And then the fourth example here is the performative utterances that normally are given to people to say either in courts or during wedding ceremonies. I will, I do, and all that. Okay, and then I've added one with the example that I showed you in the previous example, statement with a variable, with a verbal undefined. Those statements are not proposition. Okay, for you to appreciate what I have just showed you, let me just show you a question that the computer science student had to solve in what do you call it, during the time you were writing your algebra. So let's check that past question. I hope it's open so that I don't spend time here. Okay. So this is discrete mathematics. Yes, computer science paper. That was in May 2026. Exactly this. Look at question number 1. Now, section A. Which of the following statements are not propositions? Which of the following statements are not propositions? And those that are propositions, they are truth values. So in this question, you are supposed to answer 3 things. Determine whether a statement is a proposition or it is not, and then determine the truth value. Because you see the answers here, the answers have been arranged in the format, those that are not. So those that are not will come first, followed by those that are, and then their truth values. So it's a simple question, but you must follow the instructions. So let's use the knowledge we have and determine whether these are propositions or not. So 2n, 2 raised to the power n is greater than or equal to 100. Is this a proposition based on what we've done so far?
No.
Not a proposition.
Okay,
Not
yeah,
a
so this is not a proposition. This first one is not a proposition. Now, how old are you? Is this a proposition?
Not a proposition.
Not a
And
proposition.
this is also not a proposition. Now, drilling for oil harms aquatic life. Is it a proposition?
Yes.
Yeah.
Yes, because this statement can either be true or false. And then we have 4 plus x is equal to 5. Okay. So this is also not a proposition. Okay. And then 2 times 7 is greater than 14. Yes. Is this a proposition? Yes. Yes. So where is everybody? Angela and all the ladies. Please, I hope you follow this example. This one has a variable. This one is a question. And this one too has a variable. Okay,
Yeah.
so that is why they are not. Now the rest are. So when you are choosing, you choose those are not I, and IV. I, and IV. And those that are I. So the answer should be C. And then their truth values. Okay, so this is a very a beautiful way of answering. Is there a question?
Yes, please.
Okay, go ahead, Bernard.
The 2 times, Chris, can you go down, please? 2 times
Okay.
7 is greater than 14.
Yes.
2 times 7 is 14. And 14 is equal to 14. So I don't know why it's greater than 14. That should be.
I hope you were here from the beginning. The examples in the PowerPoint, you realize there was 5 plus 2 is equal to 7. And then there was 3 times something is greater than 18. 3 times 6 is equal to 18. Okay, 3 times 6 is equal to 18, but we wrote 3 times 6 is greater than 18. Your job is not to check the answer. So your job is to check, is this statement true? Is this statement false? That's all. If you're able to tell that it's true, then it's a proposition. If you're able to tell that it's false, then it is a proposition. Okay, so if the answer is true or false, then we are okay to say that it's a proposition. If you can't tell that a statement is true or it is false, then that is one way of saying this statement is not a proposition. Okay, so I hope this definition is clear. We are going to go and look at how to represent it. Let's see whether there's a question here. Okay, somebody has answered it, Dan, so I'm seeing your answers in the chat. Okay, now let's now take what we do with when a statement is a proposition. Now, when we know that they are propositions, number one, we are going to represent them as variables. And in most literature, the variables, we start naming them from the letter P. Very few materials will name propositions as A, B, C, the capital A, capital B, capital C, on and on. It normally starts from P, Q, and R. I'm saying this because if you choose to do this in an exam, you virtually will be saying things like this. I mean, I'm showing you, let me show you some of the tutorial questions you have to deal with later. Let me see, worksheet 1. This worksheet 1, you see, construct the truth table for this. This is where we are going. So you see, we see P, we see Q, we see R. Okay. Then you draw the truth table. So you see the letters, they are all starting from P, Q, R. Hardly do you see a question that deals with A, B, C, D. So I'm just recommending that when you come across these logical statements, propositional logical statements, please stick to its definition, and that we use variables starting from P, where P should be your first variable, Q should be your second, R should be your third, S should be your fourth, on and on and on and on. So the number of statements will determine the number of variables. So that's the first thing. So I have an example here that says that the earth is flat. I'm calling it P. Somebody called Kate is a doctor. I'm calling it Q. 29 is a prime number. I am calling it R. Now, these statements can neither be true or they can be false. Some are definitely false. Some are definitely true. Okay, so they are propositions. Now, what do we want to do with them? First of all, we are going to join these statements with what we call connectives. Now, the connectives are quite a lot. So the first thing I want you to do or be familiar with are the names of the connectives. Okay, so I should have done this before you came in, but I can do it here. Let's just speak. So we are looking at the names of the connectives. Now, the first one is called the negation. There's some of these names can be found in the next slide, but it's being used in problems. So negation, another word for negation is called complement. Sometimes we use the word not or complement. So that's the first one. Now, the second one is the connective. Now, I need to be giving you the symbols. Should I use bold? Let me not use bold. Let me just write. So the symbol for this, the symbol for negation is on the calculator. I can only use this, but if I use equation editor, let me show you. If I use equation editor, there are other ways of representing negation. So negation can be represented as the symbol you see here. Wow, where are my symbols? Okay, I have to pick it from operators. Yes, the symbol. Please, can you see? I hope you can see it. So that symbol you have here. So you can either have this tweedle sign here or the symbol, it thinks I'm writing an equation. The symbol that I have here. Okay, so either this or that. This is negation. Now then, let me number them so that you can follow. So that's the first one. The second one is the connective AND, A-N-D. Now, AND, in most literature, we call it conjunction. Conjunction. Please, the symbol of AND is, again, I can only use the equation editor to represent it. So let me open the equation editor to show you. The symbol is like an A without a dash. An A without a dash in between it. Again, you can find it in the operators using math, what do you call it, math type. So if you are typing, those who may end up writing exams online, then you must be familiar with these things. Okay, so this AND is like an A without a dash. Now, then let's look at the third one. The third one is known as OR, the connective OR. OR. The other name for OR is a disjunction. And the symbol for a disjunction is simply the symbol like a V. Now, let's come to the fourth one. There are 6 of them, I think 6. So the fourth one, we have the connective exclusive OR. Exclusive OR. Now, some books will call it EXOR or XOR. Again, for this, I have to borrow the equation editor to be able to show you exclusive OR. Again, I have to go to symbols. Well, where is it? Is it symbols or basic? It's a circle with a plus inside. I have to look for that symbol. Circle with a plus. Yeah, this one. So that is exclusive OR symbol. Now then we have biconditional. Biconditional, the English word is if and only if. If and only if. Again, you need the equation editor to find that symbol. Don't know whether I can see it here immediately. It's an arrow on both sides of an equation. Maybe it will be in basic. Biconditional. Okay, so it's either this. Okay, you can either use this or you can use equal to sign with an arrow on both sides. So either this or that. Then the last one is conditional. Conditional, the English word is if and then. If and then. Or implication. Some books use implies. Now, what's the symbol for this? Now, this one is also going to use either one arrow. Okay, I can do it in the PowerPoint like this, like that, either this, or when you go to the equation editor, you can use a double arrow. Okay, like this with an arrow at the end, okay? So this is biconditional. Okay, so these are the connectives that you are supposed to be familiar with. But most often we will be dealing with the first three. The first three. They are the first three, or the first three, and then the last one. You see that a lot in a lot of questions. So we are going to go through how these connectives are used. First of all, know how to draw the truth table and then how to use them. Now, what is a truth table? Some of the connectives I mentioned are shown here. This is a truth table. So majority of today's time will be spent in drawing this. Okay, so how do you draw a truth table for it? We are going to borrow the symbol 2 raised to the power n to be able to draw the truth table for these statements. When we are done, then I'll come back to these connectives here and then tell you the rules for each of them. When we have negation, for example, what do you do? When you have conjunction and, for example, what do you do? On and on and on. When you have or, what do you do? What are the rules for this? Okay, so I can better explain this using the Excel document normally that I use. So allow me to show you that document, and then we'll take them one by one to be able to draw the truth table for these statements. Okay, so on your screen, you should have the Excel document showing. Michael, what's your question, please?
Sir, please, the conjunction. So if I don't use this A without a bar and I use just dot, is it wrong?
Please, that dot is used correctly when we are not under logic. We are now under Boolean. You are correct. The connective end, when it is converted to a Boolean variable, a Boolean system, it becomes multiplication. So it's correct, but we don't use that in propositional logic. When you go to Boolean, the connective or becomes plus addition, and the connective and becomes multiplication dot. So yes, you're actually right. Just that in logic, no, we use the symbols, the one that looks like an A without a dash, and then the one that looks like a V for or, not the addition. Okay, so that is the way for when we get there. You see that I'll change all this, the rule for all the connectives, and they will tell you why they are doing that, because somebody developed another way of representing logical tables, not using these symbols, but using multiplication and using addition. Okay. Okay, so thank you for your question, Michael. Now, so we want to understand what a truth table is. Please, you will definitely get a question in the exam that you need to know how to draw a truth table. So please, if you are not able to follow what I'm doing, please stop me, I'll go over. If I should end on this, it's better, because next week I have to apply these rules in proving things. So make sure you follow the rules. Now, first of all, what are we trying to do? We are saying that, number one, every propositional statement gives you two possibilities. Please remember that when this statement that we have in here, Kate is a doctor, it can be true or false. The earth is flat. Obviously, it is false. 29 is a prime number. We know it is true. But the first example that I gave you, today is Monday. Today is actually Saturday. So today's lecture, being on a Saturday, that statement happens to be false. But the lectures that I have on Monday, that statement happens to be true. So we are saying that every statement has two possibilities. What are the two possibilities? It can either be true or it can be false. That is why we are going to borrow the use of the binary formula, 2 raised to the power n. Okay? The number 2 means that the statement can either be true or false. That's why we are using the value 2. So the n now also stands for the possible propositions you are joining. If you have one proposition, then I'll use P. When I have two propositions, n is equal to 2, I'm going to use PQ. When I have 3 propositions, I'm going to use P, Q, and R. Okay, so that is how we develop the table for the truth table. This is how a table looks like. It's just a column with rows. 2 columns with rows, 3 columns with rows. Okay, so let's now take each statement one by one. When n is equal to 1, we are going to substitute n is equal to 1 into the formula 2 raised to the power 1. Now, 2 raised to the power 1, we know that the answer is going to be 2. Okay? Everybody knows that the answer is going to be 2. So it means that when you have one statement like P, Kate is a doctor, or today is Monday, it is supposed to give you 2 possible truth values. This 2 means that 2 possible truth values. Now, how do you determine the truth values of this statement? And that is a technique I want to share with you this morning. It's now afternoon, early afternoon. So you take the result of 2 raised to the power n and divide that statement by 2. The answer you get is going to tell you how to share the true or false. So 2 divided by 2 will give you 1. Now, what does that mean? Now, that means that here, out of the, out of the 2 rows, remember, 2 raised to the power 1 gives you 2 rows. 2 rows of your truth table, what you are going to do is that you pick 1 row like this and let it be true. In other words, let it be 1 or T, and then followed by another 1 row, and you let that value to be false. False, F-A-L-S. In other words, let it be 0. So all I'm saying is that this table you have here, because when I divide 2 raised to the power 2, which is 2 by 2, and I got 1, this 1 means that out of this 2 row, let the first row be true, T, let the second row be false, F. Okay? Sometimes I use T and I use F, or sometimes I use 1 and I use 0, whichever one is you're convenient with. But let's start with T and F. When we are very sure of ourselves, we start converting them to 1s and 0s. So that gives you 1 true and 1 false. Now, what if n is equal to 2? So when n is equal to 2, you are going to deal with 2 raised to the power 2. Now, 2 raised to the power 2 is going to give you 4. It means that these 2 statements, when they are combined, their possible truth values should be 4 rows. Row 1, row 2, row 3, row 4. Again, how do you share the possible truth values? How do you know whether P has all of them being true, all of them being false, or some are true or some are false? That is what we are trying to determine. So for you to know the way to share the true or false for the first statement, you take the result of 2 raised to the power 2, which is 4. And then you divide 4 by 2. Always divide the result by 2. The answer you get is a way to share. The answer is 2. Now, okay, so it means that we are going to share the true or false 2, 2. So it means that out of the 4 rows, you are going to pick 2 rows and make it to be true, then followed by the other 2 rows, and then you are going to make that one to be equal to false. So here, when I come here, 2 rows will be true, true, followed by 2 rows will be false, false. That will give you your first column or your first statement. Now, then for the Q, also having 4 rows, how do I share the true or false? Now, the result you got from the first one, which is 2, the first division, take that result 2, and then divide again by 2. Always divide by 2. The answer you will get is a way to share the true or false. Again, you are supposed to have 4 rows. There are supposed to be 4 rows for the second statement. But this time, because you got the ratio to be 1, you pick 1 row, and then you let it be true, and then followed by the other row, you let that one to be false, and then you repeat this order till you fill up the 4. Repeat this order to fill up the 4 rows. So here, for the Q, the first row, we have 1, 1. So 1 true, followed by 1 false, 1 true, followed by 1 false. So you see that when there are 2 statements, either both of them are true, or one is true, the other is false, or the other is false, one is true, or both are false. Okay? So, okay, Angela, your hand is up.
Okay, sir, please, I didn't get the Q very well. Can you please go right
Okay,
there?
so the Q, first of all, and the P give us 2. That is 4 divided by 2, give us 2. Now to get the Q, you take the 2 that you got from here, this 2, and you bring it here. So then, and then also divide again. So I divided that 2 again by 2. You always divide the ratios by 2. And then I got 1. 2 divided by 2 gives me 1. What does the 1 mean? The 1 means that out of these 4 rows, 1 row, I'll make it true, followed by the other row, I'll make it false. Then I repeat that order, the repetition of 1 true, 1 false. So I repeated the third row to be true and the fourth row to be false. So I got 1 true, 1 false, 1 true, 1 false, because the answer was 1. 1 means that the number of ways I'm sharing the true or false, 1 at a time, 1 true, 1 false, 1 true, 1 false. Just like the first one, when I got 2, I shared the true or false, 2 truths, 2 false, 2 truths, 2 false, depending on how many rows I have. Okay,
Understood.
so
Thank you.
welcome. Now, we'll do one last one, and then I will just briefly test you if n is bigger. How do you handle this? So let's pick 2 raised to the power 3. Now, 2 raised to the power 3, based on what we know, will give us 8. Okay, so the 8. Okay, so if those who are following, we should have 8 rows, and the statement should be P, Q, and R. And these are my 8 rows. Again, how do I share them? Okay, so you take the number 8 here, and then you divide it by 2. The answer you get will be the way to share the true or false. 8 divided by 2 will give you 4. So it means that out of these 8 rows, 4 of the rows, I'm going to make it true, like this. 1, 2, 3, 4. So 4 truths, followed by 4 false. F, 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 F. That gives you 4, 4 from the ratio we got here. Okay, so how will the Q be shared? The possible truth value for the Q. You pick the number 4. Again, you divide by 2 again. The result you get is a way to share the truth values for Q. This time, 4 divided by 2 will give you 2. Okay, so what will Q be? What will Q be?
2 true, 2 false.
2 true, false.
Okay, good. Then you repeat that order, 2 truths and 2 false. Exactly. Okay. Then the last one, R, we are going to pick the 2, which is the division of 4 divided by 2. Pick that 2 and divide again by 2. And the result is the way we are going to share the last one. We get 1. Okay. So out of these 8 rows, you are going to share the true or false one at a time. Okay. So that gives you a true, a false,
True, false, true, false. Yes.
Okay, great. I'm glad we are all getting this. Basically that. Okay, so those who are already spoiling my, what's the word? They are conquering my mid-sem. What's the word? My Socrative. I want to just go there briefly. Is it there here? This is a Socrative. You see, some people are killing my things. They are doing so well. Some already are getting 10 over 10. I don't know how you did it, but so you see, I want a question. Is it here or it will be in the other one? Okay, it's not here, but look at a question like this. Hopefully next week you do this one. Where is the question? Yes, look at question number 8. Can you see number 8? If the truth value of P or Q is 2 raised to the power 3 is this, then what's the truth value of P implying Q? 2 raised to the power 3. So by the time we are through with what we are going to do today, by next week, when you are given a statement, they tell you 2 raised to the power 3, then they will ask you, what are the truth value for, let's say, P? What are the truth value for Q? What are the truth value for Y? So it's important that this formula that we are learning to determine the possible truth values you will learn to follow them very well. Okay, so let's make sure everybody gets this. So can you help me with this? If n is equal to 5, what is 2 raised to the power 5? We are not going to draw the table, but let's illustrate it. What is 3 raised to the power 5?
32.
32. Okay. So 32, the 5 will stand for P1, Q2, R3, S4, and T5. How many truths will be for P? Just tell me the number. How many truths and how many false?
16 truths.
Is it 8 or 16?
16.
16.
So the answer is 16.
Okay, so 16 truths followed by 16 false.
16
isn't it?
false.
Okay, now when we
Yeah.
come to Q, how will you share
Yes.
Q?
8
8
truth
truths,
and
8
8
truths,
false.
8 truths false.
false.
8 truths and 8 false. And then we repeat. Okay, remember, you repeat to form the 32 rows. Now, R will be how many truths and how many false?
4 truth,
4 true,
4
4
false.
4
false.
truths and then 4 and 4 false. Again, then you repeat this order. And then S will be what? Is it not 2 truths
2 true, 2 false.
and 2 false? And then again, you repeat. Then the
1
last
true,
one,
1 false.
1 true, followed by 1. Then you repeat. Okay, good.
Sir, we like this one in this format.
No, because if I want to do this, hopefully give me up to next week. Then you see me do 32. Look at 32. You see 32. It can be done. Just that it's just time consuming. Yeah. We'll get there. But for now, I'm assuming that you know what will go into the first table, you know what will go into the second column, and you know what goes in the third and the fourth. Okay, so this one is just to help us know what is involved. Okay, so we spent virtually about an hour. Now it's time to now take the connectives. We take the connectives and we'll finish with a question. So we want to learn the various connectives, the rules for the connectives. Okay, we take them one by one. And then when we take the rule, then we are going to use a rule to be able to join two statements so that you are able to tell what the rules are and what they do to the truth table. So let's take the first one. The first one is negation. Now, the rules, I have summarized them on the right-hand side, okay, in the Excel document. If I haven't sent it, I will drop it in the chat room, or I'll drop it with your refs, or put it on the LMS at the end so that you can also follow through with what we are doing. So this is a rule. Now, remember that the connective negation or not or complement is a symbol that looks like the twiddle sign or the sign like a subtraction with a line coming down. Now, this is a rule. It says that if your original truth value is true, that is 1, then complement it or negate it, then it becomes 0, which is false. But if the original truth value is 0, which is false, you complement it. Now, what I'm about to do is I'm going to draw the truth table, not using TS. I'll be using ones and zeros. So one statement, P and 2 raised to the power 1, you remember we got true and false, 1 and 0. So 1 followed by 0. So what this is telling us that if the original truth table is 1, then when you complement it, it becomes 0. If the original truth value is 0, when you complement it, it becomes 1. So
1.
Oh, yes. So that is how the truth value for negation looks like. When you negate a statement, the truth values will change to the opposite one. If it's true, it becomes false. So for example, if I give you a statement, today is Monday, the negation will be today is not Monday. So the truth table, in drawing them, instead of 1, 0, it becomes 0, 1. Okay, so that's the rule number 1. We want to look at all the 6 rules. So it's good this thing is being recorded so that you can play them back. By the way, there are videos of this also on the LMS, old videos. So the ones that do not have students in class that have explained all this. So we are 100 right now. So those who are not here, they will have the opportunity to watch it as well. And I beg you, please try and make sure you watch this if you are not in class today, so that next week it doesn't look like all this seems to be absurd to you. Now, rule number 2 is and. And is conjunction. Please, the best way to remember conjunction is the word both. The word both. So conjunction is when both of the two statements that you are combining, like P and Q, look at the rule where both are true, then the combination P and Q is true. So when both of the two statements are true, that rule, then the combination P and Q will be true. So the rule is both. If both are not true, then it must be something else. So this is a symbol for and. So we want to draw the truth table for 2 raised to the power 2 because now we are joining two things. Remember, 2 raised to the power 2 gives you 4. 4 means true, 1, 1, followed by 0, 0. And then you divide the second one by 2, you get 1, 1 true, 1 false, 1 true, 1 false. So this is the truth table for 2 statements. Now, where do you have, which row do you have P, Q together are true? Which row is that?
Row 1.
Row 1. Okay, row 1. So that is the only place
Row 1
that
and
P and
row
Q.
4.
No, row 4, both are false. We said both must be true.
Okay.
So row 1 is where both of them are true. So the rest of the row 2 will be false, row 3 will be false, row 4 will be false. So P and Q, you are going to have 1, 0, 0, 0 for 2 raised to the power 2. Now let's come to the third connective, the connective or. Now, or, the best way to remember or is the word at least. If you're familiar with mathematics, when you say at least means one or more. So when you're joining two statements with or, when at least one of the two statements you are joining is true, then the combination of P or Q is true, at least one. Okay? So again, unlike and, that both must be true, for this one, at least one must be true. So again, let's look at the table. 1, 1, 0, 0, followed by 1, 0, 1, and then 0. Now, which row do you have at least? At least one of the two statements being true.
Row 2 and row 3.
Row 2 and 3, is that all? At least
Row
means
1,
what?
2, 3.
Row 1, 2,
And
3.
row 1.
Exactly, and row 1, 2. So row 1, you have more than at least one. You have both. So at least means one or more. So this 1, 1 will be 1, 1, 0 will be 1, 0, 1 will be 1, but 0, 0, we don't have at least one. That will be false. Okay, now then I'm going to look at the third. Is it the third? The fourth one, we said exclusive or. So I'm going to jump this one and go to exclusive or. This is a rule for or. The key word here is exactly one must be true. So exactly one of the two statements must be true. Then the combination P exclusive or is true. So this table, where do you have exactly one to be true? Which row do you have exactly one to be true?
Row 2 and 3.
Row 2 and 3. So that is the only place where the truth value of P exclusive or Q will be true. Okay, so when both are true will be false. When both are false will also be false. Okay, so that was I think the fourth one. The fifth one was biconditional. The biconditional connective. The word is if and only if. Now let's look at the rule. Now, if your truth value is the same as mine, then P biconditional Q is true. If your truth value is the same as mine, then when we are joined using the connective biconditional, then our truth value, our truth table will be true. So again, 1, 1, 0, 0, and then 1, 0, 1, 0. Where do you have the truth value of P and Q together are the same truth values?
Row 1.
That's 1,
Row 1 and row 4.
Row 1.
Row 1 and row 4. Okay, that means both are either true or both are either false. And therefore, The rest will be false, false. Okay. Now, I am leaving the last connective for last because of its controversial nature. And there is so much we need to know about it before I even come to the table to draw it. So I am going to, first of all, go to the PowerPoint, tell you all the terminologies that the conditional connective is used for. I've written some of them here, but let's see from the PowerPoint so that if you forget, you know where you can pick your resources from. So this is the if and then connective. It is called if P then Q. The symbol is this implication sign. Now, before the rule, when you have two statements that you are using implication, P implying Q, if P is on the left and Q is on the right, then we call it implication, implies. Now, if you swap their positions, if Q rather now is on the left and then P is on the right, we call it converse. So it's still implication, but it is called the converse of the original statement. Please, at this stage, I want you to be familiar with terminologies, okay? I want you to be familiar with the terminologies. So kindly please go over the first one of the connective. My internet made me, oh, I didn't see this earlier. Who was this? I couldn't even tell. I think that was the end connective. Please, if you still have a challenge, I'll go over with an example, okay? I'm just seeing this in the chat. Okay, so we said the implication or the conditional connective, P implying Q. If you change their order, Q implying P, then it becomes converse, okay? Or if you negate, okay, that's Hakim, I've sent you. If you negate P and let it imply negation of Q, it's called the inverse. And then if you negate Q and let it imply the negation of P, it's called contrapositive. So the word implies, or the word if and then, they can use the word converse, they can use the word inverse, they can use the word contrapositive. All these terminologies means implication, just that what is on the left may be different from what is on the right. That's the first information I need you to remember. Now, the second one, and the most important one, is this. You can find this on page 27 if you download Kenneth Rosen. Now, again, P implying Q that you see here can be represented in, is it 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, actually 13 different ways. So there are 13 ways of replying or representing P implying Q. Either they use if and then. So for example, if you are looking at today's Monday, and the Q stands for tomorrow is Saturday, then you are saying that if today is Monday, then tomorrow is Saturday. Now, if you look at the one on the right, you can say that if today is Monday implies tomorrow is Saturday. Or you can say today is Monday only if tomorrow is Saturday. Or you can use the word tomorrow is Saturday when today is Monday. All these several ways of writing P implying Q is one of the ways why this connective is very important, but sometimes very difficult for students to remember. So at this stage, I just want you to be familiar that implication, the connective implies, it has more than one way of being named or being described in a question. Okay, so that's one of the things. Now let's go back to the Excel and take the rule. Then we take an example for all of them. So these are the words that some of them I've written here: converse, inverse, contrapositive, necessary, sufficient, when, and all that. Now this is the rule, it's on the right. Now the rule says that if you are joining two statements using P implying Q, if P is on the left like this, we call that P the premise. And if its Q is on the right, we call the Q conclusion. Now the rule says that, look at the rule where the premise is true, 1, followed by the conclusion is false, 0. That connective or that rule where you have true followed by false, 1, 0, it will give you false. So all the connectives that we solved so far, it is only this connective that you will learn how to find when it is false. It is easier that way. If you want to learn how it is true, you have to learn 3 different types of rules. And I think that will be too much to remember. So here, look for the rule where the premise is true, followed by the rule where the conclusion is false. Those who like football, the number 10 used to be Abedipele's number. So if you remember number 10, 1 on the left, 0 on the right, it will give you 0. So that's a summary of trying to remember the rule. So let's look at the truth table. 2 raised to the power 2, we get 1, 1, 0, 0, followed by 1, 0, and then 1 and 0. So where do we have the left for P is 1, the right for Q is 0. Which row is that?
Row 2.
Row 2. Okay, so that will be row 2. So that is the only place where the truth value of P implying Q will be false. Everything else will be true. And this is what makes this connective very, 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 very interesting. True, true is true. That one we don't have a problem. False, true is true. We don't have a problem. But what about false, false? So when you use implies, you can give a false statement followed by another false statement. When we join them with implication, it becomes true. That is what makes this if and then that powerful. Okay. So the next few minutes that is left, I want us to practice these connectives. So we've gone through like actually 3 sessions of topics based on what we've done so far. First, we learned the definition of logic. Then we came to look at how to draw the truth table. And then we learned the connectives and their names. The final one is to learn the rules for the connectives. So what is left is what questions can we solve using these connectives? Now, I have listed quite a lot of them, but the first one is that you can use this to solve that a statement is a tautology. What is a tautology? It's when the truth value gives you true throughout. You can also use this statement to solve a question that is a contradiction. That is when your truth table will give you false throughout. And then you can use this statement to find when a statement is a contingency. When a problem is a contingency. And then you can use it to prove valid argument. That one, I will look at that and logical equivalence probably next week. So I want us to end with a very simple example that I have in my lecture material. This is a question. What is the truth value of the compound? Either the moon is made of green cheese and Nana Aponsa III had 3 wives, or it is not true that the African ape is extinct. I'm repeating it. Either the moon is made of green cheese, Nana Aponsa III had 3 wives, or it's not true that the African ape is extinct. Now, if you should ever get a problem like this, there are certain things you need to do so that you can get your truth table correct. The first one is number 1, identify all the connectives in the question. Number 2, identify the propositions in the question. When you identify the propositions, it will tell you whether your statements are 2, or they are 3, or they are more than that. And then number 3, you draw the truth table that represents the various propositions and then the connectives. So from this problem, what is the truth value of the compound proposition? Either the moon is made of green cheese, and now Aponsa had 3 wives, or it's not true that the African ape is extinct. What are the connectives here? What are the connectives here? So Hakim, when I'm doing this, I'll go over the negation connective, if that is what you were not able to see. What are the English words that are connectives in this problem?
It's and not.
Okay, so we have and, which is I'll borrow this symbol, and then we have or, which I'm going to borrow this symbol, and then we have the not symbol, NOT, and I'm going to borrow that symbol to represent it. So now we've identified all the things in question 1. Now, by the way, in English, what English word goes with the word all?
Either.
Okay, so the word either goes with all. So even though either is not a connective, it is actually telling us what 2 things we are going to join. The phrases we are going to join. Either tells us either this or that. So it helps us. So take that one out. Now, so the problem here, let's take the word either. Let's say the word and. Let's take the word or. Let's say the word not. What is left should be your proposition. Now, remember, propositions are named or are numbered from P on and on. So if I remove the word either, what English phrase or sentence represents my first proposition?
The mood is made of green cheese.
The mood is made of green cheese, which is not true, obviously, but we want to learn something. Then if you remove and, what is the next proposition?
Nana Ponsan the third
had 3 wives.
So Nana Ponsan the third had 3 wives. Okay. Now then, if you remove the word or, remove the word not. Okay. So all that phrase, or and not, what will be your third statement?
The African ape is
The African ape
It's true that the African ape is.
Is it true that
Okay, you don't bring the word it is true. Because when you say something is true, you're already placing a truth value on it. So you remove that word
and it
as
seems
well.
you have even settled down.
The African ape is extinct. The African ape is extinct. Now that should make you realize that PQR means that I have 3. 2 is a power 3. 2 is a power 3. And therefore, immediately, my table should be 8 divided by 2 gives me 4, 1, 1, 1, 1, then 4 zeros, 1, 2, 3, 4. And then divide 4 by 2, you get 2 trues, 2 false, 2 trues, and 2 false. Divide 2 by 2, you get 1, 1 true, 1 false, 1 true, 1 false, 1 true, 1 false. Okay, so this is where it becomes handy. It comes in handy if you understand what it's all about. Now, what we need to do next is pick the statement and the connectives one by one. Our first connective was and. So what proposition and which propositions are being joined with the word and?
P and Q.
P and Q. Thank you. So we come here. We are going to have the letter P and Q. Now, what's the rule for and? I'm sure some of you may have forgotten by now. It means both must be true. Both must be true. So where do we have the column P? Where do we have both of them being true?
Row 1, row 2.
Row 1. Row 1
and row 2.
No. Row 2 is not part.
So look at it. This P, look at PQ. Where do we have both of them being true?
Row 1 and row 2.
Row 1 and row 2. So the rest will be false throughout. Okay, now the next connective is the connective or. If we are following, we've done and. Now it's coming to or. Now to be able to get what is joining to or, you first must look at what is on the left-hand side of or and what is on the right-hand side of or. So let's pick the right-hand side first. Which phrase or which connective or connective and a phrase is on the right-hand side of or? This is or. Or is this symbol, this word?
Yeah, the African ape is extinct.
Okay, so the African ape is extinct. And that should be R. But what symbol or what connective is in front of R? The word it is not true, isn't it?
Yes.
So it means that should be negation of R, isn't it?
Yes.
Okay, so we have to have negation of R. It's on the right-hand side of or. Now, let's come to the left-hand side. So on the left-hand side, what phrase is on the left-hand side of the connective or?
Nana Ponsan the third.
P and Q.
Okay, now I've had 3 different answers. Nana Ponsan. Nana Ponsan is in green. It's actually on the left. But please remember that we said or goes with the word either. So we say either this or that. So it means that the word either, everything after the word either is on the left of or before the word or comes in. So it's not only Nana Ponsan the third had 3 wives, that is on the left.
Okay.
Please, are you following? It's either from the moon all the way out to wives. the moon all the way up to Ys is on the left-hand side of O. So you will pick the moon that have been joined with Ys, and that we've already done. We got P and Q. That is on the left. Okay? So it means that the whole question here should be P and Q or not R. That is what this phrase is you've been asked to solve. So let's go back to our table. We have found P and Q. Now we must join P and Q with not R. So we need to create not R before we can come and join it with P and Q. Okay, so is it Akim? Please, how do you use negation? We said negation, when the original truth value is true, you negate it, it becomes false. When the original truth value is false, when you negate it, it becomes true. So negation of R, what will it be?
0.
0, 1.
0, 1, 0, 1, 0, 1, 0, 1.
Okay, great. So you virtually negate everything that originally was R. It becomes negation of R. So that was the first connective. Okay, so now we are going to join the P we have found right now and Q we found earlier to not R. That would be the final thing. Now P and Q we've already found here 1, 1, 0, 0, 0, 0, 0. And then not R we just found is 0, 1, 0, 1, 0, 1, 0, 1. Now what is the rule for all? The word is at least. Okay, so look at the value from row 1, 1, 0. What will it give me?
1.
1. 1, 1. What will it give me?
0.
1. No, 1, 1. What will it give me?
1.
1.
Okay. Then 0, 0. 0. 0. 0, 1. 1. 0, 0 be 0. 1.
1.
Be 1.
0.
That will be 0. And that will be 1.
1.
Okay, so that is what this question is you are being asked to do. Okay, so there are quite a few more, but I will want to end here. Maybe, or we should do one more. Maybe we should do one more exercise. We are supposed to end at 12:30.
One more.
1:30. Okay, so let's do one more, and then I will show you what your assignments are, and then you practice them hopefully before we meet next week. So the next example, let P stand for roses are red. So I've written here roses are red. And then Q be the proposition violets are blue. Now, express each of the following proposition using logical expressions. What are the logical expressions? That is the variables and their connectives. So question number 1, if roses are not red, then violets are not blue. So I've written here, what are the connectives? Then we write the answer here. So in this question, what connectives are being used here? You do go through the same thing with every problem. What are the connectives here?
If, then.
Yeah, exactly. If and then. Okay, so if and then. Now, if and then, remember, it's the implication sign. Okay. Now, then what is the next connective?
Not.
And not, we know it has to do with the twiddle sign. Okay, so if we remove the word if, not, and then, we know that we've already been told that P stands for roses are red. So roses are red is P. Violets are blue is Q. So if you say, if roses are not red, then violets are not blue. So how will we represent this symbolically? Roses are red is P. So roses are not red will be what?
Twiddle P.
A twiddle P. Thank you.
Yeah.
Okay. Then the word then means that we are using the implication sign, this. And we have violets are not blue. So what would that be?
The dodo Q.
The twiddle Q. Thank you. So this becomes negation of P implying negation of Q. Should I go over?
Yes, sir.
If roses are not red, then violets are not blue. if roses are not red, then violets are not blue. Roses are red, it's P. So when you say roses are not red, it becomes negation of P, like this. If and then is a symbol, the implication sign. And then violets are not blue becomes negation of Q. Okay? Okay, now let's come to B. Roses are red or violets are not blue. Again, what's the connective here?
Or.
Not.
Or followed by
Not.
Not.
Okay, so not is the Twitter sign. So now roses are red. That is P.
Yeah.
What is it joining to violets are not blue? What connective is between them?
Disjunction.
No, disjunction. Yes, disjunction is all. Thank you. So roses are red or, that is the V. Violets are not. So not will be negation of Q. Okay, negation of Q. Now this one, if you get this one, I'll be happy power. Either roses are red or violets are blue, but not both. What connective is here?
Or.
You think it is or? Are you sure?
Either or.
Yes, or.
It's actually not.
Or.
No, it's not or. Look at it. Here, look at the summary here. Look at the biconditional. What's the definition of a biconditional? That is if P, here, exclusive or rather, exclusive or. Either P or Q, but not both. This word, when they use the word but not both, you remember that exclusive or exactly one must be true?
Yes.
You remember? So another way of saying that exactly one must be true is also saying but not both. Okay, so the problem here is not all. It's not the normal all. It is exclusive all, XOR. That is a circle with a plus. I don't know how to draw a circle with a plus. I can only use a bracket. Okay, so this is when you use the word either roses are red or violets are not blue, but not both. The word either or doesn't necessarily mean that it's talking about all. It's talking about exclusive or because they've added the word but not both. So here it should be P exclusive or, that is circle with a plus, or Q. Okay, now this part is the conversion from the phrases to symbols. The whole issue now comes to the truth table here. Prove that A and B are the same. That is logical equivalence. Okay, so let's now take what we have drawn here. They're saying that A, this is A, and that is B. Show that these two statements are the same. So because we are dealing with PQ, my truth table should be 2 raised to the power 2. I should have 1, 1, 0, 0. Q should be 1, 0, 1, 0. Now, so if you look at the question, I need to do not P, I need to do not Q, so far as these two things are concerned. So I'll create not P, and then I also create not Q. Okay, now P is 1, 1, 0, 0. So what would be not P?
0, 0, 1, 1.
0, 0, 1, 1.
0, 1, 1. And then what would be not Q?
0, 1, 0, 1.
0, 1, 0, 1. Okay, so now the left-hand side of my inequality or my logical equivalence will be the answer for A. Look at A, not P. So not P implying, this time using the one line, not Q. I mean, I hope you can, well, I've been using this, so let me use that. Not Q. And then on the right-hand side, I should have P or not Q. So we are going to join this to this to get this. Now, this was the last connective I showed you earlier. I said when you are using if and then or using implication, the left-hand side, or the term on the left, you should look for true. The term on the right, you should look for false. So which row do we have 1, 0? If we join these two things,
3.
Which row do we have 1, 0?
Row 3.
Row 3. And that is the only one that will be false. Everything else will be true. So 110 followed by 1. And then the same statement. Now we are picking this column and joining it with not Q. So I've highlighted them in pink so that you can see. All says at least one must be true. So what is 1, 0? What will it give me?
1.
1. Row 1. Then row 2 is 1, 1. What would that give me?
1.
0.
1. 1. 1, 1 is 1. All says at least one must be true. Then we have 0, 0. What would that give me?
0.
0. And then we have 0, 1. What would that give me?
1.
1.
That gives you 1. Now, do you see that the truth value for the first one is the same as the truth value, the way they are arranged? They are the same?
Yes.
Okay,
Yes.
so this is what we mean by two statements are logically equivalent. In English, the statements are not the same. If roses are not red, then violets are not blue. Roses are red or violets are not blue. In the English phrase, are not the same statement, but logically, with the connectives we have been given, we can show that they are the same. Okay, so this is where I will end today's lecture. We've gone through quite a lot of things. So I recommend that if you go to the LMS, where are we? Is that it? Yeah, so there is a worksheet on, first of all, there's a group assignment. Please, the group assignment, there are 2. I hope, do I have it? Hey, where is it? Quiz on logic. Okay, I don't see it here. The quiz on logic and, okay, so it means that it's here. There are 2 group assignments here. When you click on this, it's rather downloading for me. I wanted you to see, I don't need it downloaded. So there are 2 group assignments. The first one, quiz on logic, the first one here is what I want you to try your hands on. Now, I don't have it open. If I have it open, let me just open it for you. So quiz on logic is quite a lot of truth table drawing. So the first is quiz on logic. So please, this is supposed to be a group assignment. So you do them and submit one solution as groups. I don't know whether your old groups are still working, then you use that. So all you're supposed to do is that pick each of the statements that have been written in zeros and ones to represent, let's say, your first statement P, the second one to be Q, and join them with or. Okay, so what is this or that? What is this and that? And what is this exclusive or that? That will help you to practice the connective or and an exclusive or. So question 1 is practicing using these binary digits, connecting them with the connective and or and exclusive or. Question 2 is also the same thing, but this time you are connecting 3 things. So you do the ones in bracket first. Join this with this using or. The symbol here is or, and then here you use and. Okay. Then question 3 is the last example we just did a few minutes ago. These are not story problems. They're giving you the statements. So when you take P and join it with Q, today we just done P and Q. Check whether it's the logically equivalent to not P or Q. If they are the same, then you say they are logically equivalent. Now, this last one, I will leave it for now. If I want to go to it, it will take me about 20 minutes to explain everything. But if you want to do it, just like we did with the Nana Ponsa, find out what are the connectives here. You see that there's if here. It means that if it's a connective, we see that there's an and here. You see that there's an or here, but it is no. So it means you have to negate all. And then you identify how many propositions are here. If you're able to identify the propositions, then you can be able to draw the truth table. So this is what I want you to do as group. Then the last one is the worksheets. Please Please, the worksheets, there are a lot, but I only give you one. If you go to the LMS, you see, no, this is engineering. Okay. So this is worksheet 1. I only give you one. So that is the one I'm referring to here. That is the worksheet 1. So you have, I think, 6 questions. The first one, you are supposed to find a truth table for this. Okay, construct a truth table for this. The second one, they give you the truth table and show whether this truth table, are they the same? Complete the truth table for this. Another truth table. Then question 3, you are supposed to find out whether this statement, P or Q or R, that is this column, when you draw this column, the fourth column, will it be the same as the last column? Okay. And then question 4, again, decide whether this is a proposition, this is tautology. Remember, tautology is when your truth values will always give you false. That's tautology, or will always give you true. Tautology is true and contradiction is false. Now, question 5 to the down, that one, okay, 5 is also tautology. I think question 6 is when you are not supposed to use the truth table. For that, if you want to try it, then please, you must finish the PowerPoint. I haven't finished the PowerPoint. So please, if you can't do these ones, this is what I'm talking about. The PowerPoint, going to the bottom, you see that there are some rules, something like modus ponens, modus tollens, the laws of logic. Okay. I won't recommend that I won't ask these things in the exam, but in solving problems, sometimes they'll tell you solve the problems without using the truth table. So this one is telling you without using truth table, can you solve this? You need to know the rules and the laws. So question 6, question 7, and I think question 8 and 9 and 10, they are all asking you to do that. So please, you can solve up to question 5, basically, because that will ask you to use a truth table. Okay, again, please, this is a practice. This is a practice. Worksheets are not needed to be submitted per se. Please take note. Worksheets, you don't need to submit them. Group assignments, you need to submit them. But worksheets actually helps you to be familiar with what we have done so far. Okay, so please add this to the Socrative. And then I think by next week, when I come doing valid arguments, you will be familiar with the connectives that I have shown you so far. Okay, any questions? I'm done. Any questions? One more. Okay. Okay, so if you don't have any questions, then we'll end on this. Kindly go over the connectives again before next week's lecture, at least just the connectives. It will make the understanding easier. If you want to read ahead, just continue the PowerPoint. You will realize what valid arguments are. And like I said, please, all that I've done today, if you are on the LMS, if you are here, there are videos, there are lecture videos for all the lectures I've done. These are videos. This is a video for valid argument. This is a video for connectives. And then these are the videos for propositional logic. All the things I've done, there are lecture videos here. So if the things are not clear, please just take your time and watch these videos so that you will be familiar with the terminologies and the connectives. Okay, so enjoy the rest of the week. God willing, next week we'll continue from this as well. God bless you.
Manotete, I beg. Oh.
Aha, menim sɛ obi bɛkɔ de amebisa guy baako na ɔsɛ obi mfe ha nti menim sɛ
Master, mute your mic.
I go for the
Imano
Classic officer will boom by or cousin of a family by maintaining. Oh, okay, okay. The battery. Oh, bye. Gas cylinder, I say 150 cedis.
Emmanuel Tete.
Bon, sorry.
Oh, yeah, the gas, I say.